Okay, folks, I just want to give you the answer key to exam one. Unfortunately, I cannot use the whiteboard here, so I'm just gonna talk through it, and hopefully you'll get the idea. And when you get your exams back, you can either come to my office hours or you can take it to the tutor and solve these questions. And also, please utilize the exam correction tools I put in place. If you want to correct your mistakes and learn, chances are you haven't seen the last of these things. All right, so let's just start. Page number one asks us with question number one. It says give systematic or common name indicated by the following. I'm pretty sure this is straightforward. Product A is, or compound A is aniline, compound B is toluene, compound C is benzoic acid, compound D is cyclopentadiene. Part B of the first question asks us to convert benzene into orthotoluidine. It has orthotoluidine has an amino group and a methyl group in 1,2 position, which is an orthomethyl aniline, if you will. So you may use any reagents, including organic compounds of 3 carbons or less. I'm gonna get started with a benzene first. Okay, let's get started with a benzene. The first thing I'm going to do, of course, my ring is as active as it gets right now. And remember, one thing you should recall about this question is if I want to put the ortho position in both of my substitutions on my benzene ring are activators, the major product I'm going to obtain from this is going to be a para product. So that is why in this question you definitely have to block the para position and then first until you're done with the reaction using sulfonation and then remove the sulfonate group. So okay, start with benzene, right? So after you start with benzene, uh, do Friedel-Crafts alkylation using methyl chloride in the presence of aluminum chloride. Step number one, that will give you toluene. Step number two, use the product from that one, toluene, and use sulfonate group at this time. So you gotta put a sulfonate group so that you block that para position, and you put on a sulfonate group on a benzene ring by using sulfur trioxide in the presence of sulfuric acid. Now we have our sulfonate group at the para position. That's step number two. Now I'm gonna go to step number three. Step number three is it should be a nitration. That is the only way so far we do know of putting a nitrogen containing compound on our benzene ring. So we're gonna use nitric acid in the presence of sulfuric acid again, and that is gonna put a nitro group at the ortho position right next to the methyl group. So the methyl group and the nitro group at this point are 1, 2, with the sulfonate group at the para position at the 4, at position number 4, if you start counting from the methyl group number 1. So after that, then what we're gonna do is let's just remove the sulfonate group if you want at this time. Just give it some heat, give it some acid. That is gonna take care of the sulfonate group. What you have now is a nitrotoluene, an orthonitrotoluene. Then do Clemenson's reduction using zinc and mercury in the presence of hydrochloric acid. You got your products. That will conclude the story of that question. All right, so part C. Which of the above questions, which of the above is anti-aromatic? I'm pretty sure this is clear for everybody. Which of the above compounds can be converted to benzoic acid? Toluene can easily be converted to benzoic acid by using potassium permanganate. That's oxidation you've done in the lab. Okay, so later on down the line, if you want, you can convert aniline to benzoic acid. You can remove the amino group from a benzene ring by first reacting it with sodium nitrate and then bring in phosphoric acid as a second step. So that will take care of the nitro group, and the nitro group will be gone in the form of nitrogen, and we'll come to that reaction when we are going to discuss when we are going to discuss amines. So I'm on E now. So E, which of the above compounds will show strong absorption at 1683 in the IR spectrum? What group would you attribute this absorption to? That will be compound C, which will be benzoic acid. The 1683 strong absorption comes from the carbonyl group. Select the most reactive compound towards electrophilic aromatic substitution and give all organic compounds or all organic products when reacted with nitric acid in the presence of sulfuric acid. Indicate the major and minor product if more than one product is expected. Alright, so the most reactive ring we see here, the most reactive ring I see here is the aniline. So go from there, put on the nitro group at the para position, the major product, the ortho, the minor product. Part G is going to ask me which of the compound will test positive for unsaturation using bromine? Okay, do you know which one?
Can you explain that, sir?
So that will be the cyclopentadiene, right?
Oh,
Because it's alkene,
Okay.
right?
Okay, yeah.
So the others are aromatic compounds, so they will not test positive.
That's true.
Okay. So number 2 is draw mechanism. That's Friedel-Crafts alkylation, right?
Okay.
So